We're going. Thanks for coming, guys. It's not really working well, is it?
It's not very working well.
All right, we'll still use it anyway. So thanks for coming, guys. Hey, Keith. How's it going? We got Bartek here today. He's going to talk about metaprogramming with Scala. I don't know much about it. I'm here to learn myself. So
I hope you're not the only one.
Yeah.
So I can share something new with you. So yes, magic at compile time. Metaprogramming in Scala. Today we will do like an overview and kind of use cases for metaprogramming, right? And even if you are not doing Scala in everyday work, maybe you will find some kind of the inspiration to look at similar tools in your language of choice. So please don't run away after a few slides. I put the magical cap here because the stuff which we'll be doing today is a bit, it might be considered as a bit crazy. So let's go. Okay, so I will introduce myself first. My name is Bartosz. I work in Agoda. This is my Twitter account if somebody wants to follow me, but I'm not active there recently. And I have a small blog where I put small examples of things which interest me, right? So one of the things which you can find on my blog is the examples from today's talk. So if you will find interesting what I say, you can find GitHub repositories and some detailed explanation of code in this blog, right? And normally this slide is prepared because I gave this talk previously, and in this time on this slide I always say that we are recruiting and so on, but I'm not gonna say that I'm gonna Meetup, right? So okay, let's jump into Scala Meta. Scala Meta is a tool. It's a clean new implementation of metaprogramming framework. This is the first sentence from the documentation. And what does it mean? So before we will start, let's make a traditional survey. Who is doing Scala in everyday work? One person. Okay, fine. So let's keep it abstract. Let's keep this talk abstract. So who heard about metaprogramming in general?
Oh, here.
No, that's more people. So I'm not asking about did you hear about Scala Meta, because that's obvious that you probably didn't. So let's establish some timeline for the metaprogramming toolkit in Scala. So you have a experimental feature called macros. Whatever this macros is, it was like 6 years ago announced in the Scala 2.10, and these macros were experimental for around 6 years, right? And then in the 2015, the Scala Meta library, whatever it is, the Scala Meta was released, right? And this is something different than Scala macros, right? And if you watch the Scala conferences, Scala presentation, you will find that Scala Days is like the most popular Scala conference, where the creator of the language, Martin Odersky, came on the stage and he announced that the macros will be deprecated, will be removed from the language. So you might be thinking, okay, cool, so we don't use Scala and you are talking about tools which will be deprecated, right? But that was Friday in Scala Days, and in Saturday in Scala Days, so that's the updated timeline, and the Saturday in Scala Days, the creator of macros, Eugene Burmako, came on the stage and announced new implementation of macros based on the Scala Meta, whatever the Scala Meta is, based on the Scala Meta library, right? So this is current timeline. So if you will be interested into digging into Scala macros, just to play around, this is current timeline 1 year ago, right? Of course, everything changes in the speed of light in this metaprogramming area of the language. And a few months ago, in October, I think, the Scala team announced that they changed their mind, and the new implementation of Scala macros will be built on top of something else. They don't know what now. So this is updated, the timeline. But what I want to present you today is like a very abstract idea of macros and metaprogramming, how you can use it. So I will show you examples of macros with the API of the Scala Meta thing, right? So if you will read about tools, watch the talks about tools written in Scala. For example, Apache Spark. This is the slide from the Scala Days, right? And on the slide, Matei Zaharia, the creator of one of the creators of the Spark. He's explaining how future versions of Spark, the machine learning framework, the future versions of Spark will have better API, more developer friendly because of the Scala macros and because of metaprogramming in general, right? And you will find more and more examples like that, like more and more presentations. When you watch the presentations about some libraries, about some internal stuff in Scala, you will find that somebody somehow uses macros to achieve their goal, right? So who uses metaprogramming in the Scala ecosystem? So in Scala you have superstars, like in all of the languages, right? You have the libraries which everybody uses, everybody knows, and so on. And I listed them here. And today we'll focus on the Play framework. Play framework is like Ruby on Rails, model view controller framework written in Scala, also in Java. And so let's explain what is metaprogramming. So the prefix meta is used to mean about its own category, right? So for example, if you say a joke about other joke, it's a meta joke, right? If you have a data which explains other data, it's a metadata. And when you have a program which programs other program, it's a metaprogram. And why the hell you want to have a program which programs other program? Doesn't make sense, right? You want to have a program which programs database, which programs server. So the reason is you are lazy, right? I assume you are lazy, but in Saturday you are here, so maybe I'm wrong. And because you are lazy, you want to have this and moreover, you want to have this kind of transformation at compile time, right? So you want to have this nice, small, red, shiny piece of syntax at compile time transformed to something very complicated and very powerful. You want to use this machine because it's powerful, big, but it's also heavy, it's hard to operate, it's hard to learn, and so on. And you want to use this small, nice piece of syntax. Let's stick to terminology of programming, right? So that's the main abstract idea about metaprogramming. And to show you the use case, I will show you transposing case class to the JSON, right? It's very common in whatever language of choice, right? You have a class and you want to build a JSON from it, or otherwise, right? So how you can do in Play framework? Don't look at the syntax because it's not important at all in this example. You have some methods, right? You have to specify field, you have to specify the type, and you need to do this for every of the field of the JSON. Makes sense, right? But let's think about code on the left. So this definition of the class, right? Let's think about this code as a bag of words, right? Set of tokens. Let's be more precise. And if you would have a program which would program this program and take those words, rearrange them a little bit, add some new syntax, you know, generate the code at compile time, you could achieve code on the right, right? So that's the main idea. That's not my idea, of course. Somebody implemented this using macros in Scala. Now we'll be talking about macros in Scala. So this is macro, right? This JSON write is a macro which at compile time will produce this amount, gigantic, enormous amount of boilerplate code, right? So that's the idea. So let's look at the very simple example. You can find it in the blog if you want to clone it and play around with it. You have a failing method. Nobody's from Scala here, so nobody will say that this method is returning unit. That's fine. But this doesn't matter. This method is fake, right? This method has some type parameters. This method has some body. It's not important. What you want to do is wrap this method into the try-catch block and repeat some number of times, right? This is your use case. You want to do this. And how you can do this? Don't look at the code. It's not important. What is important? You have a for loop. You specify the number of repetitions. You invoke the code. If the code succeeds, you return it. If it not succeeds, you repeat until it succeeds, right? Very simple use case. So what's wrong with that code? Actually, what would you want to avoid here? So this use case shows you that you need to touch the code, right? So developer, to achieve this very simple goal, needs to go modify the method, add some for loop, and so on, right? So you need to modify the method. So the perfect scenario would be to not touch the method at all, right? Have some annotation which under the hood at compile time will generate the same as in the play JSON example, will generate boilerplate code, right? And this is what we want to achieve using Scala macros. So Scala macros, you will have option, you will have possibility to write an annotation, to define your annotation, which at compile time will generate rest of the code, right? So this is exactly what we are gonna to do. And let's look at this slide, and don't look too close at it, right? What is important, this import statement. To write the macro, you need to import the Scala meta library. You remember the timeline. I told you the Scala macros are based on Scala meta, right? So you import Scala meta, first line. Second line, this is the name of your annotation. This is some parameter which you want to pass. In my example, it's number of repetitions. And this is boilerplate, and this is boilerplate. What is important is this meta sign. This meta sign means, okay, here I'm implementing the annotation, and this is what is important, right? And if you will look at this, if you know Scala, or did you, when you looked at Scala, when you saw some Scala code, you would be interested about this line. What the hell is that, right? What is this Q interpolator? In every language, you have S interpolator for building strings, for example, right? You have different interpolators for building different constructions. But what is Q? So let's look closer, right? This Q is called quasi-quotes. It's very weird, strange name. And what this quasi-quotes allows you is it allows you to construct or deconstruct code, right? So in this simple one-liner, we are pattern matching the code, right? And if you found this case, that code looks like that, and this case, this pattern is taken from documentation, right? So if you have some definition with some name, with some type parameters, with some parameters, and so on and so on. So this is case for method, right? So if you are found the method, then we are going further to body of the annotation and the real implementation of the macro, right? Which is not important right now. And you might ask, what is this 2 dots? 3 dots means like Scala can have one set of type parameters and multiple sets of arguments. The method can have, multiple sets of arguments and one set of type parameters. So this is like a shorthand for the pattern explaining the list or list of lists, right? So this is the body of the annotation. And I told you with quasi-quotes you can deconstruct code, you can also construct Scala code. And what I want to highlight here is, if you know Scala or you don't know Scala, that's not important, it's human readable, right? It's a code which I showed you 2 slides before when I told you I want to implement this code, right? And constructing code with Scala meta is as simple as that, right? So you have a quasi-quotes where inside you put human readable code and parameters which you extracted from code written by developers. So in this slide, we extracted, for example, the name of the method. We extracted type parameters of the method, and body of the method, right? On this slide, we are using these parameters to build the expected code, right? So that's the idea. And what I want to highlight here is this quasi-quotes, right? So this quasi-quotes is a huge thing because the quasi-quotes in the human readable way can allow you to construct abstract syntax tree, right? So abstract syntax tree is some API which you can use by yourself and build your own AST tree. And on the right you have example, right? So for example, for functional conference string, it's pretty simple. It's an object called literal which takes some value, right? And this is the AST which you build from the simple string. But even for such a simple case like x plus y, look at how does it look under the hood, right? Under the hood is not readable at all. It's like set of some arguments, a set of some objects which are constructed. Right? So this quasi-quotes is like hiding the internals of the AST abstract syntax tree implementation, right? So it's like user-friendly, more user-friendly stuff. Other use case, for example, you want to have when I was looking for the use case for the macros, I went to Stack Overflow for tag macros, and I looked for some of the questions which people had. And people will have this kind of example. Hey, I want to have the possibility to, at compile time, generate the method which will transform me user object to map. And map is like first argument is the name of the field of the case class, and the second and the value of the key is the value of the object, right? So I want to build something like that. And so in Scala macro, with Scala macros, which I showed you in 2 slides before, this is what we want to achieve. We want to have the annotation, which I called mapable. That's arbitrary, name is arbitrary. And at compile time, you will transform the user to the map, which is keys are name of the object parameters and the values are values, right? And that's the implementation. And let's keep looking at the code. I know when people are looking at the code, they are falling asleep immediately, right? So let's keep looking at the code. What I want to highlight, idea is the same. Importing Scala meta, name of the annotation, boilerplate, meta, and we are doing. And what we are doing, first, case. We are doing exactly the same as in the previous example. We go to the documentation of macros. We check that for the class, you see, for the class, we have different pattern because class looks a bit different than the method, makes sense, right? And okay, we extracted everything what is important from the class, and then we are doing something with the implementation of our macro, which is not important for now, right? So what I want to highlight here, imagine that you have, you don't have it, right? Imagine that you don't have this quasi-quotes, you don't have this pattern matching in Scala and so on and so on. Pattern matching in any language, right? So imagine that you are taking the file, the Scala file, for example, and you are dealing with the string. And you want to have the name of the class, simple stuff. You are parsing the whole Scala file or for whole any language file, right? And this file has, I don't know, 15 classes, right? So how you are gonna extract for each class the name of the class, right? You need to build some complex regex, right? There is a way to do this, but it will be pain, right? With Scala Meta, I can show you on one slide 2 different scenarios with 2 rules which you need to apply. Go to documentation, check the pattern, and you are ready to go, right? Okay, so let's keep the implementation. You can check on the blog if you will be interested. The thing is, you extracted everything, you apply some logic on top of it, and you build expected behavior, right? So let's not look at it. Don't look at it. It's too boring for Saturday. Okay, so long story short, we talked about Scala macros, which I told you are a bit experimental, are still not production ready, right? But they are still widely used by the Scala libraries, right? As I told you. But the main dish is actually something different, and this is production ready, and this is called Scala Meta. And is Scala Meta the same as macros, right? And the answer is no. Scala Meta is something different. So what is macros doing? Macros are generating the code, generating the boilerplate, right? You have, for example, annotation. You replace repeated code with compile time generation of that code, right? That's macros. And Scala Meta is working more on the context of whole project, right? So for example, you import Scala Meta, and what you can do with Scala Meta. In Scala Meta, you can traverse all of your files, all of your Scala files in your project, right? And you can use the same API I showed you in the macros with this quasi-quotes thing, so you can traverse your file, traverse your Scala objects, extract what is important from it, and build different objects, or build some tools, right? So when I was playing with Scala Meta, I decided to build something like that. I had my project, which has dependencies. I mean, not dependencies, which has a structure. The classes in my project, they had a structure, right? So I had an interface smartphone, I had an extending class phone or iPhone, and so on, right? So I had the idea to use Scala Meta to take all of my Scala files, right? Do some logic on top of it, and produce a JSON for this nice and shiny JavaScript library to show me the dependencies between classes, right? So that's the use case for Scala Meta, for example. Other use case, I told you about play is like a Rails, right? That play is like a Rails in Scala. So why Rails is popular, for example. I was working on with Rails a few years ago, and what I liked about Rails is this kind of notion of convention over configuration, or some convention over configuration, right? So if you follow the convention, you don't need to configure the framework because it works out of the box, right? If you put the files into the controllers package or controllers folder, it will work, right? You don't need to configure it or do something additional, it will just work. But the biggest issue which I had with Rails is that this language is, that Rails is based on Ruby, right? And Ruby is dynamically typed language. And if you don't follow these conventions, sometimes you might have runtime exception saying, hey, you are not following the convention, right? It's not working, which is not very good and not very user-friendly, right? So imagine you can have your play application, you have your application, right? And you have a tool which will traverse all of your code and apply this kind of convention checker for your project, right? So at compile time, you can catch the problems, right? The problems with the, for example, with the structure of your code, right? So that's the difference between Scala Meta, Scala Macros. Scala Meta works on top of whole project. Scala Macros works in terms of annotated definition, right? So with Scala Meta, you have power to do anything you want with the annotated definition, method, value, class, right? You have power to do this. With Scala Macros, you work more on the whole project, but you are not generating anything. You are analyzing it, right? And you might think about Scala Meta. Am I boring or not? Guys, that's not very boring?
Yeah, keep going.
Okay. Because I'm not sure I should continue or not, so thanks for cheering up. So, Scala Meta. Okay, quickly. Don't worry, it's not long. It's like 10 more minutes and I'm finished. Don't worry. So, Scala Meta is you might think about Scala Meta as some kind of tool which you can inject into different compilation phases. Very difficult terms, right? So you have in Compilers 101 in university, lexical analysis, parsing, semantic analysis, optimization, code generations. Every compiler follows this compilation steps, right? And Scala Meta gives you a slightly different API with slightly different use cases for different compilation level, right? So for example, in lexical analysis, what is a lexical analyzer? Lexical analyzer takes your code, doesn't care about is it correct or not, it's just check the tokens, right? Is this keyword valid or not, for example, right? So let's look at the example. So what will lexical analyzer do in this case? It will check if value is a keyword, and it is in Scala. It will take the value, it will take the y, it will take the equality, the assignment sign, it will take x, equality sign, and the 12th number, right? It will take it as it is. It will take also the spaces, commas, everything. So at lexical analysis stage, you are not caring about the correctness of the code. You are just caring about the tokens. And why you want to care about tokens, right? So this is how you can use it in Scala Meta. You import Scala Meta, the same as in the macros example. And when you imported this, you have implicits. Implicits are the compile time extensions to the objects, right? So you import something which gives you additional methods to the, for example, primitive objects like the string, right? Normally you don't have the method tokenize on your string, right? But we imported Scala Meta, and magically you have a tokenized method which results in success or error. And if it resulted in the success, okay, if it resulted in the success, you have the list of all tokens, right? So you are traversing your code, you are tokenizing your code, and you have value, you have space, you have y, you have space, exactly what we have in the previous slide, right? So we are not caring about is it correct code or not, it's just giving us the keywords of our code, right? You see the difference? Equality sign and assignment sign. This is what lexical analyzer is doing. It's not caring if it's correct or not. It just knows that 2 assignment signs is equality, right? It's not 2 assignments. This is lexical analyzer. What lexical analyzer is doing. You can print the structure of the code to see where exactly this is for debugging purposes. So where exactly in your line your token is. And you can print the nice syntax just to check how it looks like for human readable stuff, right? So let's look at the use case of this. Why you want to tokenize your code? For example, you can do this for syntax checking, right? So you have in Scala, you have something called whatever it is. You can take it or return null. I know. It shouldn't be null, but whatever. It is the case, right? But in Scala, you can write it more nicely with or null, right? So with this lexical analyzer API called Scala Meta, right? You can traverse your code. You can, oh, hey, I found the get or else with null, right? Because you have the list of the tokens, so you can check if the null appears after get or else. Okay, something wrong. Let's throw compile time exception saying change it to or null, or even better, change it for you, right? Change it for you. And the same example is here. You can filter some with some condition and take first or don't take it, or you can use find method, right? Or you can remove this redundant curly braces because they are redundant in this example. So you can traverse on your code on very low level, extract the code very easily, tokenize it, and do whatever you want. And the example of the tool which is heavily based on this feature of Scala Meta is called Scala FMT. This is code formatter for Scala, right? So the author of this library, did exactly that. He is traversing or the library works like that. You configure the library. It's like code formatter, simple stuff, and it applies the rules on the code which you write as a developer, right? So that's another use case of Scala Meta, of Metaprogramming. The program is programs your program, right? So how you would do this without this API? You would have to split the words. You would have to manually assign equality to the assignment, check the differences, and so on. You have to do this by yourself. With this Scala Meta tool, you can do it. The library is doing it for you, right? Okay, so we traverse our code, we split it into the tokens. Now we need to parse it, so it means we need to understand it, right? And the parsing code, in the parsing stage, parser needs to understand the code, right? So if you will traverse your code, parser will throw you exception if it's not valid, right? In the previous slide, we just take all of the tokens as they were. Now we'll try to understand the tokens. And I forgot to put import Scala Meta, right? But the rule is the same. You import Scala Meta. You have flying implicit around, which gives you like very strange methods like this parse, for example, right? And when you parse this piece of code, you parse as a type, right? So you can make the string of your code statically typed object, right? So this is not a string. After parsing, it's not a string. It's some kind of the object of Scala Meta which tells you, hey, this is a type, right? It's not a value of list. It's a type, right? And you can have different parsers for different cases, right? So in Scala, you have something like stat, which is the so for example, object stat means this is like the statement, right? And this statement you parse it with the type statement, whatever, right? You parse the case statement with the case type, right? You parse the term with the term type, and so on. So skipping this is a detail, right? You can parse your code, and when you're parsing it, you will know what type it is, right? That's the advantage of it. So let's look at the. So what's the use case? Let's go a bit higher. And what's the use case? So for example, you are applying this convention over configuration. You want to build a Rails on Scala, right? You have an object constant, where you put the string variables, right? And you name them, like you name the variable to the body, right? Okay. And your convention is the string value cannot be assigned twice to the different variables, right? And this object clearly breaks this rule. Maybe this is stupid rule, it doesn't matter, right? It's just example. So this string Ruby is assigned twice to the two different values, right? So this is the use case. And I written the method called validate if you will be interested more to dig into and look at the implementation of it. And this method validate will take a source. Source is your code. And look, this is exactly the same what we did in the macros, in the previous examples. We import Scala meta, which is not here, but it's not important. You extract what you want to extract. And what I want to extract is the object with the name constants, right? So I'm looking for the object, first of all. I have this name. I have the extended types, right? And if the name is equal to constants, then do something else. If the name is not constants, I don't want to run this validate method, right? Because my convention, I want my convention to work only for the object constants, right? And we will skip implementation. This is the implementation. The thing is, it can fit on the slide, right? So it probably is not something difficult, right? Code metrics. I showed you the fancy graph with the code with the dependencies between classes, right? So I also built like code metrics, let's call it, right? So something, if the class is bigger, if the class has big methods or huge amount of line codes, I want to make the UI look different for that class, right? I want to have bigger square or bigger circle, right? So that's another use case. We will skip the implementation, but the point is I have the object counts, which will count me the class numbers, object numbers, trait numbers, and so on. And I do exactly the same. Look, import Scala meta, I forget about that again. You have my program, my meta program starts here, code metrics. And for whatever it is in the file, I accumulate all of the files and I do some logic. For object, I take from documentation, I take the pattern for object and I do something for object. This is not important. For class, I do something for class. For trait, I do, and so on, right? So on one slide, there's a whole logic of my meta program, right? So maybe you can look for something similar in your language of choice and try to find this kind of use cases and try to find some kind of solutions and compare them to Scala meta, for example, right? Is it similar or is it better or not? Or you can have another use case, for example, you start your application and you don't want to have some kind of the definitions in this boot, right? You have the boot method, right, of your project. And you want for some kind of purpose, you don't want somebody to start some kind of the object in this class, right? So you can make a comment with threatened people, right? Or you can have like a compile time checker saying, hey, you are initializing this object, you shouldn't because somebody said this convention is not following our convention, right? Thank you. This is the quick introduction to Scala meta. I wanted to give you like an overview. I put some kind of links which I use for the preparing of this presentation. And last but not least, this link where you can find the examples from this presentation. And I hope it was not very boring. Maybe you will find the use case in your language of choice. Thank you very much. Any questions? Oh yeah.
Yeah, has anyone got any questions?
Everything is so clear. That's good, right?
What about DSLs?
What about what?
Like how can you interpret like a DSL language? So basically you create your own DSL language, and is it possible to use with Meta? Like read that call,